Hello all, welcome to another session with me, Varun at OdinSchool.
By now, by these sessions, you must have understood how our language is very important, how it plays a game changing how it actually serves as a game changing platform when you're working in the field of data science, how it is used by a lot of statisticians in and across, how it is used by a lot of data scientists. All these points by now you must already have understood. And to give you all a basic introduction about Odin School, we at Odin School are a technology upskilling platform, and we would help you continuously acquire new skills, thereby which you could stay skilled and stay ahead. And guys, my name is Varun. I come with an experience of 7 years, and I've been working as a developer and partly a trainer. And over these years of my experience, I have been able to lay my hands on HTML, CSS3, JavaScript, our language, Python, and have gained exposure into languages or concepts like machine learning, deep learning, and I've also been able to work for platforms like SAP. So yeah, that's a bit about me. And the agenda of this session is to understand what are missing values, why are missing values important, how do we handle them, and also we would be looking at a practical implementation on the R Studio, which is on the R platform. Now, talking about missing values, it is very important for us to handle missing values properly, because talking about them, whenever you talk about these values in specific, right, they help us in understanding the spread, or help us in understanding about your data or about your data set. Okay, and also there's a lot of misinterpretation, or there's a lot of negative notion in the industry saying that missing values are only to be removed, and they are not to be added. Well guys, that is completely wrong, because missing values a lot of times are also infused into the data set. Actual values are removed, missing values are introduced by different means. It could be the mean method, or it could be the median method, or whatever suits them. They find a method, and this method is also forcefully inserted into any of your data set based on the requirement. Now, whenever you work on missing values, or when you're working on NaN values, as they call it on technical parlance, if you are unable to handle them properly, you would be seeing that your result will differ. Your answer would definitely have inconsistencies. All right, and having an inconsistent answer isn't something that you would want when you're working on this platform, because if an accuracy of even 1% varies, then if we are talking about 10 to 15%, then that's a huge difference, and that is a huge actually, something that we don't want to take, a chance that we don't want to take. Now, when you talk about the techniques which we have in dealing missing data, there are five methods here. But as we all know, interpolation and data wig are methods which we have from Python. All right. In this session, we would be talking about 1, 3, and 5, and probably we'll see as we keep unfolding. Okay, so to begin with, guys, there are some very famous and very important libraries when you talk about R language for for imputation as a concept. So the first one is mice. All right. The second one that we have in order is Amelia, which is written here on the left. The third one we have is MissForest. The next one is HMISC, and finally we have MI. Well, these are some very commonly used and some very famous libraries that we have available for our language. Right? We've already covered what are the different libraries for Python on a separate tutorial. And for all those of you who have no idea, or who are new to understanding this concept, then guys, you're more than welcome to watch that on the YouTube platform. Now, going forward here, when we talk about mice, mice is abbreviated as Okay, let me write it down properly. Right. MICE is abbreviated as multivariate imputation. And this is a multivariate imputation via chained equations. Now, when we talk about understanding this, here you can say that it can take care of the uncertainty in missing values. It assumes that the data which is missing, it is missing at random, which means that the probability of a value which we have, or of the probability of a missing value, it depends mostly on the observed value, and it can be predicted by using the observed values as well. And also the most important takeaway here is it imputes data on element by element basis rather than using the whole chunk at once. All right, so this is what we should understand from mice, which uses MAR. Okay, and here there are certain methods that this package in specific uses, and it's very important for us to know what these methods are and how do we work on these methods. All right, so the first method that we have in this is PMM. We also have polyreg. We have logreg. Okay, now talking about each of them, this is predictive. Okay, predictive mean matching. This is the one which we mostly use. This is used whenever you have usage of, okay, let me just clear the screen. Right, so now it's come up with it. So PMM, which we were talking about, is mostly used when you have numbers. Whenever you have involvement of numbers, you would prefer using PMM. All right. Now after PMM, the next one we have is logreg. Logreg is generally used when you have logistic regression. All right, and this is used when you have bi or binary variables or binary values. All right, like yes and no, profit loss. So whenever it is A or B, in that case, you can use logreg. The third one that we have is polyreg. Now, when you talk about polyreg here, this is for anything which is greater than or equal to 2 or 2 values. Okay, and so yeah, these are some few methods that we use. And whenever you might want to work on this mice package, you just have to install the library. I hope you all know how to work on R by now, how to install a library. You could directly go into the tab, the fourth quadrant of your R Studio, which is here, and you have a packages tab. You can just go into it. You have an install tab there. You can select it and you can directly click on mice. If you're working on this library for the first time, then I think you should download this library immediately, install or download. And then once it is done, you can then work on the next step, which is a pattern. Or okay, you could check for pattern. Now what would pattern do? It returns a tabular form of missing values. All right. The next one, which you could use in this library, is also VIM. VIM is great when you might want to use colored visualizations of missing values. All right. Now, it's a heat map which is colored, is what you can say when we talk about VIM in specific. All right. After this, as you keep going forward, now that we have understood what is mice, let us understand the next uh, library we have in order. So after mice, the library which we were talking about is Amelia. All right, now this library in specific was named after a woman pilot. All right, and she was the first woman pilot, I suppose, and she has also she's also famous for one of her stunt with regards to flying, and since then she's become a very famous personality for almost all the flyers. Anyways, now keeping that aside, Amelia is the name of a library which we use again for handling missing values. Here, this can perform multiple imputations. That's the best part about Amelia. Now, what do we mean by multiple imputations? It can, generate imputed data sets. So it would add in new values to the data set, or it would run multiple times to deal with missing values. And what would happen because of multiple imputations? Now, for all those of you who might be considering that this is a lengthy process and this might affect the performance, well, there's another way to it. And the other way to it is when you're dealing with imputed data sets, or when you're dealing with missing values, using multiple imputations, it helps you reduce bias and also helps you increase the efficiency of your efficiency, or increase the performance of your model. All right. This is generally enabled with a bootstrap, and it can, also feature multi-core CPU. Multi-core CPU. All right. Now, whenever you're working on Amelia, Amelia makes, or Amelia works, or it uses the following principles, or it has to ensure that these following principles are there. The first one, there are a couple of principles that you should know. The first one we have is that your data set should be having multivariate normal distribution, right? It should have multivariate normal distribution, wherein it uses the covariances and the mean to summarize data. The second one that you have is MAR, that is MAR is missing at random. So these are the two assumptions that Amelia makes when you're working on this library. All right. And also there is some difference between Amelia and mice when you talk about them theoretically. So let us just understand the difference between them. That is Amelia versus mice. Now, guys, you might want to make a note of them, because, and also if you have any queries, then please use the comment section below. Me or my team, we would address you at the earliest. And now going forward, when we talk about mice, mice imputes data on variable by variable basis. All right. But when we talk about Amelia, it's not the case. All right, we've just seen what Amelia does. It uses multivariate normal distribution. So mice is element by element, whereas Amelia is multivariate. The next one, mice can handle different variables. All right. Now, when we talk about different variables, different types is, a better way to say. It can handle different types of variables. But when you talk about Amelia, here it is, whatever is the variable you feed the data with, it is most probably transformed to suit to the system. All right. And finally, mice can manage imputation of variables. But whereas when you're talking about Amelia here, it is not like that. All right, so guys, these are the few differences that we have between each of them. All right, and even here, when you might want to insert values. Okay, now we would be working on the iris data set. We'll just see how to work on iris data set in a while. I'm pretty sure you all must have an idea about what this data set is. This data set is about different variants of flowers which look almost alike. Uh, they all look alike. Okay, the flowers. Based on this information, we would be, now based on this data set which we will be working on, we would be inserting NA values. We have a data set which is very clean in the beginning, free of NA values. But we would now have to insert NA values into it. And the procedure to insert NA values is you can, there's a small code, or there is a very small functionality function to it, and that is PROD with a capital N and a capital A. Oops. Let me just write it down properly. PROD, capital N, capital A. Now this is to produce any values. Now let us say you want to do this for iris data set, or you might want to do this for whatever data set it is. Okay, you can do that, and then you can apply the NA. That is the number of NA values you're looking at, and you can here give the percentage, and it will insert 10% of NA values into your data set. It's as simple as that. And now such values are important for us to work on when you're working on any kind of a data set. All right. The next one that we have in order is MissForest. Now this library which we're talking about works a bit on the random forest kind of an algorithm. Okay, random forest and MissForest, you can say that they share the same implementation standards. All right. Okay, going forward, so here, in how does it work is the first question. What it does is it builds a random forest model for each element. Okay, so each and every element would be having a random forest model. Okay, and then it uses this model to predict missing values with the help of observed values. So here, each and every observed values which we have, they would be producing NA values based on such observations. Now here you have something called as out of bag, or OOB, very famously referred to as. You have this OOB error estimate. Now, when we talk about this OOB error estimate, it provides or it gives us a good control over the imputation process. All right, so this is what we would be working on, and here, this is what we will be working on just in a while, probably next, 10 minutes. And once we are done, once we have an understanding of the theoretical part, we'll move on to it. Okay, this model helps us, look at more closely about how accurately the model has imputed value for each variable. Okay, so it would give you each variable level description. Rather than using the word description, I think I should say accuracy. So things like these are important for us. And you have terminologies like PFC, NRMSC, so we have values like these which we would be looking at, wherein PFC is the proportion of PFC is abbreviated as the proportion of falsely classified values. Now, these values help us understand the error which is gained, or error which we have from imputing categorical values. Right, guys? So I hope you have understood what this is. And when we talk about NRMSE, which is here, NRMSE is nothing but normalized. It is S or Z, whatever should make a difference. Normalized mean squared error. Mean squared error. Now this is what, or these are the two important parameters that we would be noticing, which Miss Forest uses. The first one is PFC, and the second one is NRMSE. Now that we have an understanding about these as well, let us go further into understanding the next ones, which is HMISC. All right, now this is the next and probably the last on the panel which we have for discussion, and then we can move on to the hands-on part of it. All right, so here we see that it is a multi-purpose package, HMISC, which is highly used, or which is significantly used for data analysis, that is DA. All right, it's also used for graphics. You have good graphics or graphs based on this, and you can also use this for imputation of values. So it can be used for imputation as well, and it can be used for different model fitting as well. All right, so these are the different parameters we can use HMISC for. Okay, now here you have two powerful functions, or two really cool functions which are very frequently used. The first one is impute. I think impute is something that we use in all of them, which is something that you must have understood by now. And also we use AREGLMPUTE. All right, so these are the two highly used functions. Now, because of this function, you could say it is to allow the regression or bootstrapping of your model. Okay, so these are the two variants you could use here, and this function, it simply imputes your values from your data set based on the number that you feed. Okay, now even this model uses predictive mean matching by default to impute the missing values. All right, and as we all know, or even if you don't, then by now you should have had an understanding that predictive mean matching, it works well for continuous and categorical data. Now when we say categorical, it could be binary, which is only yes or no, or it could even be multi-level. All right, so for either of them, or for any of these, you can say it works perfectly. And in this library, the most important output parameter to consider would be your Fisher's optimum score, or Fisher's score. I don't think there is a C. It is Fisher's score. All right, and this is used when you have categorical variables, and we all know what is used when we have numerical variables. Right, guys. And there is also another library which is MI, and we wouldn't be talking about this much in detail, but just to give you an idea, MI is multiple imputation. All right, it is multiple imputations. And when you talk about MI, it has several features for dealing with missing values. All right, and when you talk about what are the different features, you have it can use PMM, and notwithstanding PMM, it can allow you to work on something called as graphical diagnostics. It can also work with Bayesian models of regression, and it can also add noise, or add NA values or add inconsistencies into imputation process to solve uh, irregular constraints. So yeah, there are many ways and many choices which you have when you are working on uh, handling missing values. And also, to be very honest, there is no one specific method which you can say is perfect or which can be used when you're working on imputation. Almost all of these methods which you see here, they're all good, and you can say that almost all of these methods are all correct, and they are all significant, and they're all correct to use in their respective times. So here you can see these are all missing values. Now, whenever we talk about missing values, it is not necessary that a missing value should only be represented with an NA or a capital NaN or not. There's no actual trend to it. Guys, missing values are represented, or missing values are, uh, missed in different ways. All right, they are just blank. Sometimes you have na dot n, you have nan dot n. So yeah, there are many ways wherein missing values are represented, and all that you got to do is identify the trend wherein the missing values are represented, and based on that, you would have to take your next course of action. All right, so that is what we mean by working on missing values. All right, now without wasting time, let us quickly move on to the R Studio platform. All right, so guys, here you see I have my R Studio. All right, so here I'm using a couple of packages. Now we all know what each package does. The first one that I'm using is mice. All right, and what is mice, guys? Please pause the video and post it in the comment section below. That would also help me know that my video, or my delivery is being understood. All right. So here now we have mice, we have Amelia, we have MissForest, and we have HMISC. All right. So to begin with, we would be okay for all those of you who are working on these libraries for the first time. You can go into packages. Once you do that, you have your install tab. You could come here and you can just type in like miss. You can just click on this, and when you do that, you can click on install, and I think you should be having the required. All right, that is the least of the things you should be worrying about. So now what we're doing is I'm using a library that is Miss Forest, and when I use this library, okay, I think this is not the first step. All right, let me. All right, so executed. Now that you see my library is executed, the next one that I would be doing is we have a data set which is inbuilt in our language. Okay, and the name of that data set is Iris. And guys, Iris is a very famous or a potential data set which a lot of us use. Iris is a very famous Iris data set, Titanic data set as well. So here I am trying to introduce the concept of missing values, and this dataset in actual does not have any missing values. Okay, but when you are, or when you're planning to work on so here is Iris. Okay, I think instead of checking it out like this, we can just click on view. So here I go. Now let me also close this. And now this is how my data set looks like. So here you can see you have the sepal length, sepal width, petal width, and the species it is, right? Now, based on this information that I have, what I would be doing is I would be producing NA values. Okay, and how am I producing NA values? I We have that function which is available in MissForest. All right, prod NA. You can go into your help. See, you have your second option. And when you do this, you can see that it is within the library MissForest. And it is to introduce missing values which are completely at random. So here, when you select 0.1, right? When you select a value of 0.1, then you would know that these values would get introduced by 10% at random. All right, so here let us now do this, and you can see when I go into my iris now, okay, iris.mis, I've renamed it to iris.mis, and when I do that, let us just check. Okay, so here you have NA values, right? So you can see that we have NA values which are introduced, and these NA values which we are talking about are the values which have been introduced just now, and we have checked how they have been populated, right? So these are missing values. Now I would want to check how many missing values we have, and you can check that with a summary. And when you do a summary, you can see that your petal your sepal length has 20 NA values. The sepal width has 16 NA values. And how would we know that? Guys, as you can see, you have your column name here. Okay, so you have your petal length, sepal width, and sepal length, wherein each of them have the NA values respectively. All right. So this is how we work on the data set, or this is how you understand summary. And we all know what summary is. Summary produces your minimum value, it produces the median, all right, it then produces the maximum value. Okay, these are the three values, and notwithstanding that, it produces the first and the third quadrants also, Q1 and Q3. So these are the values which your summary produces, and it's important for us to know them. All right, now going forward, what I'm doing is here in my next step, I am considering a subset. All right, and this subset is to remove the categorical values. Okay, and as you can see in my output, I still have species which has categorical values. No, I don't need that row here, so I'm removing that row, and then I'm again using summary, right? Summary of iris, and when I do that, we can now check it out. You don't have the fourth column at all. I'm sorry, you don't have the fifth column at all. It's completely removed. Okay, now going forward, this is how you can work, but then we are not done yet. The next part that we got to do is to the is to work on imputation. Now this is where the actual work begins. So we still have NA values, as you can see. So this is part one done. This is how you insert. Now when you talk about the next variant, that is to understand the pattern of your missing values, I would now want to use my library of mice, and I would want to work on this, which is md.pattern. All right, and what does md.pattern do? Let us check. It displays the missing data pattern. All right, and how does it display? Is it a plot or is it something like that? Let us just understand right now. Okay, so as you can see, my library, which is mice, is imported, and now I would be trying to identify or find out the pattern of my uh, data set. And my data set is not iris. Iris is my actual data set, and I am working on iris.mis. All right, so now let me go ahead and execute this. Right, so here you can see this is how we understand the output. All right. So here it is saying that there are 99 observations, okay, which have no missing values. All right. And then there are 13 observations here which have one missing value in sepal length. Okay, the last one is sepal length. So here you can see, all right, this is 12 missing values, and respectively it keeps going further. Okay, now because this is something which looks very typical to understand, this would ensure that it makes our job a bit easier. You have 99 values which have no NA values at all. You have 13 values which have NA values in sepal length. You have 12 values which have NA values in the third column. You have three NA values which are repeated for two times in these two columns. So guys, this is how we work on the on understanding the NA values here. All right. And it would just take some time and some practice for you to understand this, but I'm sure as you keep doing it, it shouldn't be a problem for us. Now, when you talk about imputing data here, I've just made some short notes that we might want to understand. Now, the number of times I want to impute is what we go, or is when we use m. Now, this is for the upcoming value, which is mice. And as you can see, the method that I'm using is PMM, and we all know what PMM is now because we have gone through that in the theory part. It is predictive mean modeling. All right, and then I have a max IT. Max IT is the maximum number of iterations that I wanted to do. See, you have max IT, and then you set seed to get the same records later on. Anyways, now I'm using my mice library. It is iris.mis. I'm using m is equal to 5, and I'm taking maximum iterations is equal to 50. Okay, so now you can see it is doing 5 iterations each, 1 2 3 4 5, and this will go on till 50. Now this is what we call as system cost, okay, or computational cost. All right, so now you can see this is the 49th iteration, which is repeating from values of 1 to 5. Then this is my 48th iteration for 1 to 5. And this process would just keep going on right from my first iteration. So this is my 6th iteration from 1 to 5, my 5th iteration from 1 to 5. So that is how we understand the usage of mice library. Now, because this is too much to understand, this way of understanding would actually make no sense and would not give us an actual insight. Let us now go ahead and use a summary. And in order to do that, I can do that using my imputed data. Here it goes. So these are the different imputed values that my system has produced for each of the elements. Okay, so this is for my sepal length. Here you can see there are values. All right. Then I have my next column, which is sepal width. And these are the places where we have NA values. NA values are not lying in all the rows, right? So based on the places where you have NA values, your system would execute stuff there. All right, this is my petal length, this is my petal width. So these are the four NA values. These are the four columns wherein the NA values have been fitted onto. Now going further, the final data set with imputed values which we're talking about, here also you can just check, and in order to do that, I would be using complete, and you can view this. So this is your first iteration. All right. Likewise, I can view any number of iteration or imputation number that I want is my second. Now, why do we need this? This is to compare how your values are working on different combinations of mean replacements. Now I would want to check if how is my engine performing when it has 2.5, how is my engine performing when it has 3, and how is my engine performing when it has 4, then probably for 1.5. So for different values, when I would want to check how my system is performing or behaving differently, I would have to introduce something called as NA values. All right. So this is what is the importance, or this is what is the thing that we need to understand here. Okay. Going forward, the next library that we would be using is Amelia. We all know what Amelia is, and we all know who she is also now. All right, let me begin with this. We first, okay, guys, if you're using something like this, then please ensure that you're also using a hash mark towards the end, because it would throw you an error otherwise. All right, so now here it goes. Now what we are doing is I'm using imputation, and we are now working on imputation using Amelia. Now you see we do not have an error anymore. All right. Now here, the step 2 that I would be working on is production of NA values at random. All right. And how would we be producing these NA values, guys? These NA values would be coming completely at random. We know that there is no specific way that we insert values. Like there's no way wherein you can say that you want an NA value to be inserted in line number 30, 35, or based on that. No, that's not the way how we do it. All right. So I hope that is understood. Now what we're doing is I am producing NA values into my iris data set. Okay. And in order to do that, when I'm using my iris data set, this time I'm producing NONA of a ratio which is 20%. All right. And when I do that, or when I introduce 20% values, I would again be passing this to the same data set, which is MIS, again iris.mis. And now my iris.mis should be having, now it should be having 20% in values. And you can see that we have values which are definitely a bit on the higher side as compared to earlier, right? So guys, this is the most important takeaway here. Now that we've introduced NA values, let us go further. And what I'm doing here, I would now use a summary. You can see that I have 35 for my first, I have 33 for my second, 19 NA values for my third, and 34 NA values for my fourth. Alright, guys, if you have any inconsistencies in understanding, please use the comment section below, and I will be more than glad to assist you with your query, because what we're talking right now is very important. All right. So, yeah, now let us take this discussion further. Now that we have understood things till here, I would now be using my next variable or my function, which is mismap. And now let us zoom this, and I think now you should be able to understand this plot which you're using is a beautiful plot. It gives you how many missing values you have vis-a-vis how many observed values you have as well. All right. And guys, whenever you're working on such values, it is very important for us to ensure that the number of values you observe or you check with are random, are also more in number, less in number, because you would want to play around with your data set, and you would want to check how different data sets perform when or how your values or how your data set reacts when you introduce higher number of NA values and lower number of NA values, just to test and see. All right. Now, what would we have because of this? Because of this, you would just be able to, gain deeper insights into your data. You would be able to understand your data set better. You would be able to work more efficiently. All right. So you would have more command over your data set. All right, so now that we have understood things till mismap, now what I'm doing is I'm using Amelia. And here, when I'm using Amelia, guys, let us just look at it. I'm using NOMS. And NOMS, what it would do is it would remove, okay, this function automatically imputes numerical columns. And if it imputes numerical columns, then I obviously wouldn't require species, which is not a numerical column. So now I would enter this, and these are the 5 imputations that it has made. Now let me check for the first imputation values. And when you click on view, you can see these are the different imputation values that have come up. All right. Now, guys, here species column you can see has a different color. All right, and also has a different flavor, feel, and look. All right, and that is because of the fact that whenever you're working on a data set, all right, whenever you're working on any kind of data set, you would have to work on different imputations, and just to have different values to know different insights. All right, so that's the next part. Let us now check for the second imputed data frame. This is it, your second one. All right, then I have my third, which is MissForest. All right, now this is the last library that we would be talking about, and in this library we would be again checking on another way about how to impute missing values. And here I mean increasing the number of missing values to 30%. All right, and how am I doing that? I'm using library of MissForest. All right, and as we all know, MissForest uses the concept of random forest to produce NA values. Okay, so I'm using prod NA,
I'm using Iris. NA values is at the 30%. All right. Now I'm using MissForest in my next step. Okay, and when I use MissForest, I would be using iris.mis because this is the place which has, or this is the data which has my 30% missing values. So I would be doing that, and I would be passing it into iris imputed values. Okay, so it is done with 5 iterations, and now I'll have to get them from my data frame, correct? And after which I would now be using mix error, and now let us check the error. So now we all know what is NRMSC and what is PFC. NRMSC is the error in continuous values, right? And this is 0.24, which is almost up to 25%. And this is PFC, which is the probability error, and this stands at 12%, and this is generally for categorical variables. Right, we have discussed each of these, and I'm sure you must have had a sound understanding about how and what they are used for. And the last one that we have on board is HMI-SC. Again, I am introducing values. Okay, now I'm producing NA values. Okay, there is, I guess, some shortage with the library HMISC. As you can see, within HMISC, there are a couple of libraries which are missing. So let us just try reinstalling this library. Guys, now this is what happens when you're working in the field of data science. Whenever you're working on libraries, there are certain libraries which might get outdated. There are certain libraries which might need update. All right, so let us just go ahead, try installing this once again. All right, so now it would take a while. Okay, now generally it does not take more than 1 to 2 minutes for a library to get installed. Okay, now this has taken less time than that. Let us now try this. Okay, it still says that there is an error, and because of this error, whenever you might want to come up with NA values, we might have a problem. So what we'll do is we'll just leave this HMISC apart for now, and let us just infer this as an understanding that whenever you're working on libraries, you might have to also not just install and go ahead. You might also have to understand the different ways to work on different libraries, understand which library would give us what as an output, and based on that, if you are able to work on any of these, I think it will be very effective, and you would also have the apt output for you to go ahead. So guys, I hope you have understood also how to come up with such a graph. We have just checked a hands-on version on RStudio using the same. All right. So talking about this, I hope you've understood what are missing values, why are missing values important, what are the different ways to handle missing values, and also how do we work on them. Right, so guys, thanks a lot for being there. This is me, Varun, your trainer, your mentor, signing off. And if in case you like the video, then guys, please do not forget to hit the like and the subscribe button, as that would encourage us to make further. And also do not forget to hit the subscribe button, because when you're doing that, including the bell icon, you would be having access to a plethora of libraries, and you will also be notified whenever we come up with a new video. All right, so thanks a lot for your patience, and I really appreciate your presence here. This is me, Varun, signing off.